SUV. This is the flagship model, and this is the breakthrough for a SUV, basically. And this kind of SUVs we see in our daily basis, but these are all called as luxury SUVs. Maybe you can take these SUVs for off-road and also during your normal driving conditions. But the people who likes to enjoy the pleasure of an SUV at the same time also want to enjoy the pleasure of luxury, some people would go for these kind of SUVs. And what kind of a car is this? This is a famous car in India, right? Toyota Innova. These are called as MUVs, which is called as multi-utility vehicle. So there is a purpose, because you can carry more than, because in a normal scenario, a car can carry 2 plus 3 or 2 plus 2, 4. But in this kind of an MUVs, you can carry more than 5, maybe 7, 8, or also today in Kia Carnival has launched with a number of cars, the number of passengers can be increased to 9. So this is called as a multi-utility vehicle. And this is a Lambo. This is the Lambo. This is Lamborghini. So what is this car purpose is to, it's a supercar. Yeah, it's basically a supercar, which means these are really the sports car. You can show off in the road by buying a sports car, but the major purpose of buying and to enjoy the sports car like Lamborghini and Ferrari is to drive in the track. So you have to drive in the sports track and to enjoy the feel of this vehicle. Something like McLaren, Ferrari, Lamborghini, something like these vehicles are called as a sports vehicles or supercars. And you could also see these kind of vehicles in the normal way, right? And these are called as pickup trucks. So these are not really cars, but this is in between a truck and a car. So this is called as pickup trucks. And this is the car which I wanted to also highlight. This is called as a hybrid vehicle. So hybrid means what? Basically, it has an engine. It also has a battery. And it has a motor associated with the battery. In normal vehicles, normal combustion vehicles, you have a battery and an engine, but not with an extra motor. And that's the difference between a hybrid car and a normal combustion powertrains. So what we have to do with a hybrid vehicle, you can also power the battery from your house, so you can charge your vehicle. At the same time, you can also use your fuel tank, so you have both the benefits when you have a hybrid car. And finally, this is a Tesla. So Tesla, what is it famous for? It's the electric powertrain. So what we call it as an electric vehicle. So that's the most reliable electric vehicle which is available in the world right now. So why I'm saying all this, why am I showing all these images? So right now I'm going back to my definition again. A car with a purpose. So which means we have seen many vehicles at the moment, right? Like SUVs, MUVs, normal sedans, pickup trucks, sports vehicles. So each vehicle has a purpose. So when you define a car should have a purpose. And of course, it should be for the roads on a desired powertrain. So what is a powertrain? So powertrain is something, it's a combination. Because previously people have defined in the way of an internal combustion engine. So let me also take you maybe back 200 centuries before, when the car was invented. Maybe in 1800 centuries, the research to the cars was going on. During that time, Carl Benz was the inventor of the first petrol engine vehicle. Previously, there were many inventors for the steam engine and also for the diesel engine, but why the name of an invention to the car has been given to Carl Benz is because he is the person who made a prototype with a petrol engine. At the same time, he could replicate the same prototype and manufacture around 30 to 40 cars of the same prototype. And he could sell those cars to the customers. And that's the reason his model was recognized and he was given the inventor of the petrol engine cars today. And after that, in 1900, Henry Ford, he took some initiatives to make some cars. So when he started making the cars, he could make a series production of up to around 150,000 vehicles. And when it moved to 1940s, Toyota Corporation Mr. Toyota, because in Japan they call it Toyota-san. He made the Toyota Corporation to make more cars. But the point is, all those vehicles were made with a normal internal combustion engine. So when this powertrain came, so it is not only the engine, it is the whole design over the engine, because it also has the control unit which has the engine. So all together it calls as a powertrain. So now what we say that we have many powertrains available. We can say we have a petrol powertrain, so it's called as a petrol engine. We have a diesel powertrain, and we also have an electric powertrain. We have a hybrid powertrain. We can also say that we have a turbo powertrain, right? The powertrain with the turbo boost. So we have many kinds of a powertrain right now defined. So now a car has to be defined in this way as an engineer. So now I repeat my definition again: a car with a purpose for the roads on a desired powertrain to meet the customer requirements. I will come to this point to meet the customer requirements later once I go through the subject in much more detail. I'm not sure whether you have heard about the concept of flying cars. I'm not sure whether you have really heard about the flying cars, but I just want to avoid one confusion here. There are no such flying cars, because the flying cars today, whatever the design available, it's not based on the normal powertrain principle. It moves on a principle called as VTOL. It is vertical takeoff and landing. That's a complete different principle. And if tomorrow, if the same companies who design the flying cars make the design such that it has 4 wheels so that it can move through the roads, at the same time, it can also take off and land on demand, then I would surely include them as also a flying car. At the moment, I will not include them as a flying car. It's just a subset of an helicopter. So helicopter also runs with the same principle of vertical takeoff and landing. So if you want to really say a flying car, then bring both the principles together, then we can include them into the cars. But as of now, it's just a flying taxi, or it's a flying machine, we can call it. Before I start again, one more point. How many of you think that automotive and the cars are mechanical subject? Because I hear this every time, because I'm basically from electrical and electronics engineering. So whenever I go and say that I work for Mercedes-Benz, then everyone asks, oh, which dealer shop? Because they say, hey, cars are mechanical topic, and how does it suit you? If you would have thought that cars and automotive are really a mechanical subject, just wipe it out of your head and throw this into the moon. Yeah? It's not at all a subject of mechanical alone. Let me give you a small explanation on that as well. Basic functionality are mechanical. We have to agree it is a mechanical subject by the base. But we also have an electrical infrastructure which is inside the vehicle, which means all the electrical engineers should also be part of a vehicle. And what about the electronics, guys? Yes, of course we have, because we call it as control units. It's not only called as a control unit, we call it as an electronic control unit. If there are electronic control units, someone should be from the electronics background should also be part of the vehicle to develop the vehicle as a whole. Then comes the department called as communication engineering. Then someone will ask, I am from the communication department, what does it mean to me again? You all speak about the navigation in the vehicles today, right? GPS, the global positioning system. The GPS and the navigation, satellite navigation, we speak about maps, self-maintained maps, self-learning maps, all those technologies are associated, which means without the support of a communication engineer, we cannot develop these technologies. A good communication engineer is required to write the right algorithm to define a navigation system. Yeah, it's not only navigation, it's called as a navigation data system together. Then what is the department? We have computer science and information technology. Of course, there is no question about it. Today, whatever we use is an embedded system. So of course, the hardware and software is there. If you would speak about the languages, C, C++, Java, Python, Perl scripting, HTML, XML, whatever you call, all those languages are required to develop a vehicle today. Even we call it as an embedded C as a separate language. But even I would say all these languages are being used today into a automotive environment today. But what does it mean for everyone? And there will be one notorious guy who will ask me this question, that what does it mean to be for a civil engineer? Then I would say that 30% of the automotive industry, if it has to run, we also need to rely on a civil engineer. How? Because a good civil engineer is required to design the whole production unit line and a full assembly line, a whole building. If there is no proper civil engineer who can really design such an environment and building for us, today we can't produce a series production vehicles. Today we speak about robotics and automations inside a plant or an assembly lines, but all these things has to be defined if you have a proper basement or a proper platform from the building perspective. So a civil engineer is required. A chemical engineer, of course, he is also required to make a proper windshields, proper plastics, and all the elements which we use, we also need, because we speak today about not only the steel, aluminum, we also speak about carbon fiber materials, which means these all things have to be designed or made by a proper chemical engineer. Excuse me, can someone go on mute, please? Okay. So before I jump into the subject, say we have got many technologies associated with the whole vehicle as a whole, but I cannot touch the whole technologies around the vehicles because there are many, more than 80, 100, 120 components in the vehicle. So I cannot touch all the components, but at least today what is happening and what is the most critical evolution and the new technologies going inside the car. It's not outside the vehicle. It is always going inside the vehicle. So as means when I say it is inside the vehicle, which means it is inside the interiors, in the dashboards. Right now we see a steering wheel. There is a display above the steering wheel. We call it as an instrumentation cluster. We have a system called as a display, 10-inch display, 12-inch display, 7-inch display. We all see it. So it's called as an infotainment system. And this is the place where a huge evolution of technology is going on, and other components are complementing it. And that's how the things are happening. So we spoke about the car, and we spoke about the importance of our engineering into the vehicle. We spoke about what is a car. So far we have completed all these three topics. So now let me go to my first slide. Before we go deep into the exact technologies which we are dealing with today, how it evolved until 2017, because today we are 2020. I have a separate slide for 2020 and future. But before 3 years, what has happened? Until before 3 years, what has happened? When we speak the car as a whole, until 1960s, please, you can observe this. Maybe I can show you with a laser pointer. You can just see there was a steering wheel, and there is some dials here. Maybe it's a tachometer, and the left called as a speedometer. The speed which tells you about the speed, which tells you about the RPM, how much it is running. We also have a fuel gauge here. You also have a temperature measurement. So these are the 4 basic components you will see in every vehicle, even today. This is the base requirement which was available since 1960. And you don't have anything like that. You had a basic radio, and you had something like the engine button to start. There was a light panels here to control the lights. and there is nothing else. Because in the older days, what we made as a car is as an interior wise, I would say the connections are completely mechanical connections, and it is the basic electrical. So the wire-to-wire connection was happening in 1960s. So when you want to really measure the speed of a vehicle and the RPM of a vehicle, you have to use the resistance. Yeah, basically that's the basic thing which we also use in our labs today to calculate the resistance. That's one of the subject in our laboratory, in our electrical or maybe an electronics laboratory to measure the resistance and capacitance and inductance of a particular device or something. So here, these are the basic principle which we were using since 1960s. And then, which means these are the basic principles. So when we have the basic features, then wiring was enough, because that's all the features we gave. But when it went to 1980s, sorry, excuse me again. Yeah, thank you. So in 1980s, there was no much development, right? What is the development you have? The same dial, same thing, but in a different fashion. Only it was on the left and right, now it has gone to right and left. And left side, they made a specific box for measuring the temperature and fuel. There was no much improvement in 1980s. And even this looks remain the same. There were no much. And what I am showing in the picture here, these vehicles were the top-end vehicles of that particular era of 1960s or 1980s. Which means you can see if there is nothing here, even the cars of the below category would not have got anything, because there were no much development, because there was a normal infrastructure of a platform for a vehicle. So when you say as a vehicle, what is the base for the vehicle? It will have 4 wheels. There will be a chassis for them. There will be an engine in the front or in the back, depends on the vehicle's architecture. And you will have a basic battery to give some basic power. But during those time, if you would remember, if you would have had a older ambassador vehicles, which we used in the 1980s or sometime, then our parents of our grandfather or grandmother, they would have taken the vehicle to the workshop every time to replace the battery, because they have to charge the battery outside, come back. But in 1980s, that was the one development it happened. They could regenerate the battery, so which means they could create a powertrain, and they could bring some control units. They also scaled up their BCM module. BCM is called as a body control module, because when they wanted to bring some features into the vehicle, they made the BCM body control module as the gateway to bring some features like this. Because inside, if you see this vehicle and if you try to disassemble the vehicle and see, you will see around more than 10,000 to 50,000 wires running inside the vehicle. So that's what it is called as the point-to-point connection. So the principle is called as point-to-point connection, which was used in these vehicle infrastructures. And moving to 1990s. And what happened in 1990s, you could see some special design here in the 1990s dashboard, right? You can see this, there are some digital things coming up here, and there are different parameters here, and there is also a small radio here. Yeah, did you see this? There's a radio here, and these radios are famous during these times of 1990s. And what was the reason there? Because until 1980s, we used a point-to-point connection network inside the vehicle. From the point-to-point construction, point-to-point network infrastructure, we moved to a different concept in 1990. That's because, thanks to Robert Bosch, because they brought the CAN protocol. So CAN is a protocol in automotive. It's a famous protocol in automotive, which is called as controller access network. Until in 1960s to 1980, you can also ask whether there are electronic control units in the vehicle. Yes, we had electronic control units in the vehicle, see, even in 1980s, but everything were wired. But in 1990, all the electronic control units were properly designed under the protocol of CAN. And in 1990, we also got a LIN protocol evolution as well. LIN is called as Local Interconnect Protocol, Networking Protocol. So why the CAN was only used in the high-end vehicles is because it was too expensive. Because that was the time CAN was evolving, and CAN follows a bus topology. So in your engineering, you would have studied about various topologies for a design, for electrical design, called as a ring topology, star topology, bus topology. So CAN is controller access network which follows a bus topology. So what is the use of a bus topology? Because if you also think about a star or a ring means it has to connect it in the form of ring. Star means one master will have multiple states in the form of a star. But here in CAN, it's a multi-master, which means if you consider it as a bus, which means it's a straight, if you consider a straight line, and you will have multiple electronic controls which can be connected to the same CAN bus, which means we have reduced the wiring inside the vehicle to 80% down when we use the CAN protocol. Which means when that complexity of point-to-point connection has been reduced to 80%, then people started thinking, okay, what we can now do to scale the interior so that we bring more features into the vehicle. Then they thought, okay, let's do it in a better way in 2000s. So in 2000s, we have more information, but because if you also see from here, the cluster remains the same. Yeah, there is no change here in the cluster. It still remains the same. Instead of 3, it has made to 5. It has become only 2x. To make it more luxury and to make it more expensive, they made 5. There is no much change here too. So what has the change happened here? If you see from here, there is a radio and there is also a CD player. Did you notice here? There's also a CD player, and until here, if you see from the 1980s part or 1990s part, see just the climate control, how it was like. This is the basic AC you had, or in India we call it as an air condition. In Western countries they have a warmer to make the vehicle to drive in the cold. So they have both the features available even in today's vehicle. So here, in 1990s, if you see there is no much change, but in 2000s you have a different concept in the AC also. You have a rotary knob. Did you see the rotary knob here? There's a small rotary knob here, and you also have CD player. You have a radio, and you also have multiple switches to handle. So how to handle these switches, and what is this rotary knob does? This is an actuator. If you would have studied it in engineering, maybe you would have noticed what is an actuator, and what is the base of an actuator? It is SCR, silicon control rectifier, or a thyristor, what we call, yeah, basic. So these are the rotary knobs behind it, and we have this CD player and radio. So this is called as a media player, and this is called as a radio, which is the base concept is tuner and media. So we have 2 separate modules here, and each has its own country. Each was a separate control unit. So in 2000, it was a both separate control unit. You have other switches here. And there is, if you see, notice the steering wheel is blank with only horn to be available. You can only blow horn by pressing it. Right. Now in 2000, during the period between 1990 to 2000, what has happened? It was an evolution of LIN and CAN. So CAN
it has a capability to handle 127 nodes at a time. And CAN has the ability to trigger the signal at the same time. It also has the capability to send the data, but the amount of data they can send is only around 8 bytes. So people thought, okay, for the basic nature, it was fine, because when you want to bring more features and more luxury inside the cabin, you need more data to be passed. So what we can do? Then they thought, why we should make two separate systems? Let's make it one, and let's make a small display, which means a display can be only a user interface. So the user can see whatever in a display, and they can combine this media and tuner together. So what they call that as a 2DIN standalone system. So then it came to the existence of a standalone system. So what is a standalone system? When you have the display and the 2DIN unit, head unit, we call it as an head unit. Head unit, I mean, if you would see from this picture in 2000s, behind the radio, this is this front plastic panel you see here. But if you take the front plastic panel, you will see an aluminum frame of box with which is a bit on the square shaped, yeah, which is aluminum box, and that box is called as an head unit. And how this size of the box is defined, we call it as 1DIN system, 2DIN system, or 2.5DIN system. These are all basic. The CD player is a 1DIN system, and this radio is a 2DIN system. Sorry, this is also a 1DIN system. And when it came here in 2010, people started making, okay, let's make a standalone system here. So when people made a standalone system, then they wanted to identify, they wanted to make, okay, let's bring all the things in one direction. So when we have a display, we also have the head unit available, and we can also bring more features. So what are the features which we can bring? Tuner, media player, and we also can bring Bluetooth at that time, because Bluetooth framework was one of the biggest thing which came into existence during that time. So if you also see from the panel here, there are numerous letters, numerous numbers here, and there are numerous buttons here. So this is the number to trigger the Bluetooth framework. So when I say Bluetooth as a whole, even here, between 2000 to 2010, we brought Bluetooth technology here. We also brought tuner, media. We also tried to bring navigation here. So navigation means GPS. Yeah, GPS provides the latitude, longitude coordinates. Then we have to make an algorithm to run, and we also need the data. So which means from where we get the data. So data has to be stored somewhere inside the system. Then came the biggest part of storage. How much storage we can place here. So now, if you also think from the design perspective of an electronic control unit, you need to have a microcontroller, which is the basic processor. You need to have the controller which has to power up the CPU, and the base will be always a bootloader. So bootloader is the one which triggers the system. Then a controller which has the power to connect to various chipsets. Like for example, tuner, we need a tuner chipset. We need a Bluetooth chipset. We have a Wi-Fi chipset, etc. So we have many chipsets available. So we also need a GPS to be available inside our head unit. So we brought GPS, satellite position. So when we know the vehicle position, we can also take the wheel speeds. We also take the wheel position, steering wheel angle. Steering wheel angle is called as the steering wheel angles, and we use the wheel position, the running wheels. It's called a gyro sensor. There's a gyro sensor there, so we try to do a matching to position the vehicle. Then we need to store the data. We can store the data inside the head unit, so we get the head unit every time. So for the vehicles until 2010, we had to update the map DBs, databases, every time, maybe in 6 months or 1 year, whenever you go to the dealer shop, you have to change the databases. So always you get the updated database, so your map is always updated. And you also have the GPS positioning available, so you can work through the navigation. And we have the Bluetooth connectivity available, and we have the storage. Everything is available right now in 2010. But at the same time, you also notice two things here. In 2010, this remains the same again. Instrumentation cluster, there's no much development. Same, it is still the same. And why? If you see from 1960s until 2010, why there is no much change here in the instrumentation panel? Because instrumentation clusters are always safety critical items. You can't change as we like. Because if there is a small driver distraction here, it is going to affect the safety of the driver, and it's only of the driver, the passenger is the whole vehicle. Which means we can't change instrumentation cluster as it is a safety critical unit, and it has to pass through the ASIL. ASIL is the safety standard. So until 2010, there was no much change in the ASIL standards. ASIL standards remain the same, and so we cannot change anything. At the same time, we also notice from here, there is a small portion here. And what does it mean here? Because you can notice from before 2000, 1990s or 1980s, 1960s, there's nothing there. But there are small peaks here, and here. And if you also go to the right there, and there is also a small peak here. And these are the extra speakers. So to give a better audio experience in the vehicle, we brought not only previously it was only 4 speakers in 4 doors. If you also notice in most of the vehicles today with the budget vehicles, like below 5 lakhs vehicles, if you even see today, it's the 4 speakers in 4 doors, and that's how the design today. But in 2010, they tried to bring more than 4, it's like a 6 to 7 speakers, maybe 2 tweeters. They also try to bring amplifiers. To power the amplifier and to send the data to the amplifier, you need more bandwidth, more speed. And as I said before in CAN protocol, right? CAN and LIN. LIN protocol, I think I didn't mention about the LIN protocol. LIN protocol is also the basic standard protocol, and it has a capability of only 10 kilobits per second. So compared to, since the CAN, it has a 1 megabits per second speed, people used to go for CAN rather than going for LIN because it's very slow. But at the same time, LIN protocol is also used in many features. For example, LIN was used in the steering wheel controls to move the doors, door windows to up and close. So people use LIN protocol there because it can be slow. There is no safety problem. There is nothing to be more faster to up and down the windows. So people started using LIN protocol, and it's much more cheaper comparing to CAN protocol. But to power up the amplifier and also to power up the tweeters, speakers, to bring 6 speakers, we need a more powerful protocol than CAN and LIN. Then everyone came with an idea of MOST. It's called as a media-oriented system transport. So what is the MOST capable of? MOST protocol is based on optical fiber. So when I say it's an optical fiber, then it should have the capability to send the data and trigger the signal in one short way. And it has the capability to have a speed of minimum 25 megabits per second until 150 megabits per second. So that was a breakthrough for the vehicles by bringing the MOST protocol, because MOST brought the complete audio experience into a new level inside every vehicles from 2010. So the MOST came and started dominating for all the vehicles for the experience. So, but the drawback of MOST is it's too expensive. It's damn expensive, MOST protocol, and the weight of the vehicle also goes high, because it's a coax cable, yeah. It's an optical fiber cable. So when you start putting the optical fiber more into the vehicle, then the weight of the vehicle also goes higher. So there was some disadvantages, and also getting this most was not that easy. So people were thinking, okay, only the premium vehicles can afford most, and the normal vehicles cannot afford most. So most came into that kind of a debate. Here, the most brought the complete level of audio into a different style in 2012. This is 2017. So now we have LIN protocol. Now I would say the point-to-point connection is completely eradicated only for basic feature. Now we have LIN protocol, CAN protocol, most protocol available. Now I think we can make the user experience into a better way, and it has been incorporated in the way that the complete dashboard changed into a different level. If you see now from this 2017 onwards, the whole instrumentation clusters, if you see here, it's in a complete analog cluster. It has completely transformed into a digital cluster. So these clusters are called as reconfigurable clusters, because if you want to change the dial pads based on your moods, you can change. For example, this is a classic dial pad. If you want to make it to a sporty dial pad, you can also change it to a sporty dial pad, and you get all the informations in digital, even the fuel details and all the things you get in digital here. And how we can start getting the digital technology because of the ADC. It's an analog digital converter. This is also a new invention that made all the analog to be transformed to digital. So this we also study in our engineering, right? Analog digital converters and digital to analog converters, vice versa. So here, if you also see, there's a huge display. And if you also see, this is the time when the software started dominating, because Google brought a new feature called as a CarPlay. That's the feature from the, Google brought the feature called as an Android Auto, and Apple brought the feature as a CarPlay. So all the software technology companies wanted to make their mark or make their footprints into the automotive industry. So they brought their own applications. So we also can integrate those applications in the way OEs wanted. So who are OEs? OEs are original equipment manufacturers. So for example, BMW, Mercedes-Benz, Volvo, Tata, Maruti Suzuki, all these called as an OEMs, yeah, original equipment manufacturers. And what they do, they can adopt these technologies and they can put it into a vehicle. So all these features started evolving, but if you also see, the complete resolution has been changed. Until this 2017, even if you also notice from here, even from 2010 and 2017, there is always a dial pad here, right? So what is the use of this dial pad? This dial pad is the one which controls the complete infotainment system. Even here, you also see here, will be a dial pad here. This is the dial pad which will control this infotainment system. So, which means you can use those dial pads to control the infotainment system. So what is the message between 2010 and 2017? Is until 2000 to 2010, everyone were focusing on standalone systems. So which means you have the display and you have the head unit, everything together. You just fix this whole unit into the system and everything works. And this is also a solution from the after sales market, even today. Something like a single system, you just fix it and everything is done. But from here onwards, we brought a new concept called as a distributed system. So what does it mean as a distributed system? It's all the displays, right? You see a display, the head unit, this knob. If you also see this knob, head unit, this display, everything is scattered. So it has been separated. Everything has to be managed in a different way. So how to do this? Because we also have a camera from the rear view. Camera image also needs to be projected back. So there is a necessity of an integration. So every company made their own components. Now onwards, what happens in vehicles are, these are all separate components. Display is one component, This rotary knobs are one component, head unit is a separate component, reverse camera is a separate component, parking sensors are different component. All those has become a separate component right now. So all these components has to be integrated together to form one single unit. And that is what we today call it as infotainment systems. Because until today, until 2010, we can also call it as an infotainment system because it has an entertainment and information. But from 2017, that word really got a meaning because we get every information. Even here, this unit is also connected to the internet, and you also have a Wi-Fi hotspot inside the system. And we also want to bring all the features. When it is connected to the internet, your options are countless, right? And if you ask something, it gets the data from everywhere. For example, if you use the Android Auto or a CarPlay as a feature, similarly, it's just your iPhone or your Android phones. See, it's just the same. If you say, hey Siri, what do you want and what's the temperature today? Even the same question, if you ask in our system also answer back saying that, hey, the temperature, weather today is something X factor, yeah, something there. So which means the speech also came into existence and speech also started evolving. But this is all part of the infotainment system until now. But I will tell you how we could really make such a complex systems in a simple way. This is our next slide, which we go. But before we go, I also want to touch on one more protocol, which is called as a FlexRay. So what is a FlexRay protocol? This FlexRay also uses the same bus topology like CAN, but the speed of the protocol is 10 times than a CAN protocol, which is 10 megabits per second is the speed of a FlexRay protocol. And where this FlexRay protocol is used really in a vehicle. If you see the safety critical modules, just like braking system or the airbags, all these are safety critical systems. These criticals needs faster responses compared to the other things. For example, this rotary knob here, it is connected to the head unit via CAN network, usually. So when you press next song or a previous song, when you try to accept, deny, it's okay. And if it takes time, like a 1 second delay or a 500 milliseconds delay or a 600 milliseconds delay, it's okay. You can handle it because it is not going to cause any damage or a catastrophic because of this change. But in case if your brake fails or your airbag doesn't booms up, what happens? It leads to a catastrophic, right? So we wanted a fast mechanism where we can handle all these techniques in a simple way. And that's how the FlexRay came into the existence. So inside the vehicle, if you also think about the FlexRay as a protocol, we also use the FlexRay protocols for the braking systems and also for airbags. Let's go. I hope everything is clear. There is no much confusion here. Okay. And from 2020, and we are today here. And what is the evolution in 2020 here? Because we see the same unit, same style, everything looks same, digital cluster, infotainment system, everything is there. There is an addition. It's a touch screen. We have an evolution of touch screens. So that's why you see in most of the vehicles today, whatever vehicles you go to the dealership and try to any OEs you go, they wanted a touch screen. Because before everyone thought touch screen is a bit not safer. But thanks to Tesla, because they came with that breakthrough of bringing the 14-inch screen inside the Tesla vehicles to bring that touch is really not a complex thing. It is the same thing. It's a nice, like the normal way. It is not going to affect anything because the whole scenario comes in a touchscreen in Tesla vehicle. So everyone started moving towards the touchscreen. But the biggest problem of a touchscreen is because when you use a rotary knob, you have some time to change and you move and act. But touch, it's so faster. It depends on the individual. Some touches slowly, some are so crazy, so they touch faster. So when you do more activities, it might crash the system. So the performance and the stability of the system are always at stake when we use a touchscreen system, and that's why it was so complex to implement as a touchscreen system in an automotive vehicle or in a vehicle, basically. Go into the future and to the evolving technologies, whatever I have mentioned here, I want to show you a small video so you will get an idea of uh, how a cockpit will look like tomorrow. I will explain you on the go. Maybe you can also follow me while I will also try to pass the videos then and there.
ఒకసారి ఏమది మళ్ళీ ఇస్తా.
There is no audio here. Please also just look into the. Yes. Do you see this video right now here? What he shows here, if you also follow my mouse pointer here, it will be easy. So this is the kind of a cluster he's focusing that tomorrow a vehicle can have. So this is the digital cluster he's focusing, and what he's trying to touch here is the infotainment systems. Okay? And this is what we have today. For example, this is the 14-inch system, a kind of a 14-inch system what Tesla is having today. And this is the kind of a digital cluster which is already available since 2017 or 2016 itself. So this is also available from before. And what are the two displays you see here? So these are the alternative for the mirrors. In every vehicle you have the side mirrors.
What's up?
So right now they are also projecting that we don't need to have a side mirror. Instead, let's try to bring the displays inside so that it is much more easy for the user to visualize. Instead of moving or turning your head to the right or to the left, you can just go down and check, hey, what is there in the left and what is there in the right, and you are there in your vehicle, and you are on the road again. So you are back on track. So which means there is an alternative for the side mirrors. And if you also see from here, there is a big display which is shown. So what does it mean? So this is the big display which you are seeing in my previous slide in 2020, a display together with instrumentation cluster and the infotainment system. But what is the difference here and there? What you see there is a normal control units, two different control units. One is an instrumentation panel and one is an infotainment system. But here what he is trying to show is a cockpit, which means cockpit is a technology where we bring both instrument cluster and infotainment together. We get this into that track. And how can these displays be extended in a vehicle? That we will see in some time.
ఉంటావా? చూడు బాగుంది.
Okay, let me also show you this. You see something here, right? What do you see here? There is a small set of some display here. This is called as a heads-up display.
See that?
So what is the scenario of heads-up display? This is the display which you see in the windshield. So what he shows is the mirror, the whole windshield. This is not called as a mirror. This is called as a windshield. So this is the display in the windshield. But you should not mistake that this windshield is being designed in the way to show the display. No, this is not the principle behind this heads-up display. This is projected technology. So the principle is projection. So this is the unit which will have the display. So it will have a display and it gets the data from So this is connected via a network. So this will have the display, and there is this display will be always inverted. The display will be inverted, and there will be a projector which is kept, which project the data into the display, and that's how you get this as a display. It's like it's a mimic. Yeah, it's not the real display, it's a mimic of projection, and you get as a feature. So this is one of the simple principle. Yeah? This is the very simple principle. We all know about the projection. Someone thought about this simple principle, and this is today it's a cash cow. Whomsoever is manufacturing a heads-up display today he is earning billions. Yeah, it's a small principle. Let me also go through the other side. So this is already explained. Okay, now this is a bit. This is quite interesting. This complete display. Let him complete. Do you see it? It's incredible, right? Because if you would have noticed, if you have followed his the way he was explaining, this is the whole display from the pillar of the driver to the pillar of the passenger. There are two pillars inside the vehicle, right? From the one side to the driver pillar, the another side is the passenger pillar. This whole display connects together, which means on your left, what you see, in India, on your right, what you see will be the instrumentation cluster, because it's in Western countries, it's on the other side, it's a left-hand drive, but in India, it's a right-hand drive. So he's explaining with the left-hand drive sequence. The left is on an instrumentation cluster, the middle is the infotainment system, and there is a right display for the passenger. So on the go, what we can also do, if a passenger can play the video games during the drive, so which means he can combine the whole infotainment and things together, because all the displays here, the details which driver sees from here. But there will be a question. On the move, there is already a safety critical protocol or a rule it's a regulation that above 6 km speed, there should not be any video to be played. It's a rule, basic rule. Yeah. So how this is really possible? Because in 2008 or 2010, I remember, because I was working on Jaguar and Land Rover's project at that time. There was a new display which was invented based on a prism concept. So what happens is the display will be the same, but when a passenger sees the display, he only sees the navigation. If the same display is viewed by the user, then the user can see the video. Which means with that principle, it was allowed to use such a display, so you don't need to stop the videos. At the same time, even though you have brought such a prism concept into a vehicle, which is still not distracting the user, the feature was still disabled, because regulation is always critical, and it is always serious, that you can't override the regulation. So which means we couldn't implement that prism concept in a vehicle because it was too serious for that time. Even today, this thing is possible. Maybe for the rear passengers, it's still possible. This kind of a playing games, maybe when you are in a standalone conditions, you can still do this activity. Having said, the main message here is the main display concept and how to do this complete scenario. And now comes the biggest topic. Now let's go back to the presentation. Okay, now we spoke about every protocol, right? We spoke about LIN protocol, we spoke about CAN protocol, we spoke about MOVES protocol, we spoke about FlexRay protocol. And with all these protocols in the pipeline, we still couldn't evolve the system into a we couldn't actually revolutionize the system, to be precise. Because to revolutionize the system, you need the access to the internet. Eileen, I think we are already on time. I think we have still more things to do. Hello?
No, you can take some time, Karthik.
It's okay?
Yeah, it's okay.
Okay. So maybe I will go through a bit more faster to complete things. So maybe. So what happened is the Ethernet revolution. What is actually the Ethernet revolution? Here, in the Ethernet is a basic TCP protocol which we study here. It's an automotive Ethernet. So Ethernet has the capability to give a speed of 100 megabits per second. So it's faster compared to any of the other protocols. At the same time, it uses this normal twisted pair, which we see in our LAN cables, home estate normally. So which means when you use a twisted pair, compared to the most and other things, it is reducing the weight of the vehicle, and it reduces the complexity. So Ethernet has becoming evolved to a greater extent, and because of Ethernet, thanks to Ethernet, that we are still online today, because we could make a new telematics unit. Telematics is a unit which we have the SIM card inside, or how maybe a Piggy, which is like a Wi-Fi hotspot or something. You can use all these telematics system inside the vehicle, so you can connect the telematics, you can connect to the browser, you can connect to the internet, you can connect to the cloud. Everything is because we have an Ethernet right now inside the vehicle. So the Ethernet is a bit expensive, but compared to the other protocols like most also have the same capability, but it is too expensive and it is not affordable. So compared to that, Ethernet is taking place right now, and it is actually started dominating. And hypervisor. And we spoke about multi-displays. And right now what we want to do, we cannot make each control units like you saw in 1970s or 1980s, where you had a separate media player unit, you have a separate tuner unit. Not like that. You want to make everything in one head unit, as a one head unit which can control both clusters and infotainment systems in one way. So the only technology which we can use is in hypervisor. So hypervisor uses a virtual mechanism where you can run more than one operating systems in a single unit. For example, in an infotainment unit, if you are using a Linux operating system, and if you're running a QNX operating system in a cluster, and if you also have an Android operating system in a different display, you can combine all the operating system into one single unit with the help of a hypervisor, because it gives us the capability to handle multiple OS in a single hardware, to be precise, single hardware. Then we have a sensor fusion. Sensor fusion is a technology part of an autonomous vehicle, because we need radar to sense the pedestrian, sense the lane, sense the pedestrian, sense the road, sense the obstacles around the vehicle. So radar is one of the mechanisms where you can get the data by emitting the radio waves. The technology is simple, but we also have cameras around the vehicle. We also speak about the 360-degree camera. We have cameras around the complete vehicle to give a complete overview of the vehicle as a whole. Yeah. So we will get more data together from each camera. We also get data from radar. So we have different sensors, and what we have to do is we have to collect the sensor data and we have to fuse it, and we need the right algorithm to fuse and make into a common data, so we can use those data into our systems. So that's one of the technology which is also evolving right now. And car as a part of an Internet of Things. So what is Internet of Things? So Internet of Things, to give you a small example, Amazon just now made a small way that you can just go into the shop, just buy it without the use of a seller. You can just show your Amazon Pay and you can just get the money. So similar like internet, when you're connected to the internet, you can also buy the applications, buy the music. You also have an insurance management, the vehicle mobility. All these things are part of Internet of Things. You can also do these things. What is augmented reality? Actually, I had a video to show you what an augmented reality is. Also to tell you what is a self-maintained maps, but I think I would like to skip these two topics because I want to show you the video. Then it is better to explain. Maybe augmented reality as a whole, if I want to explain it, maybe it is not the real picture, but you get the data, you try to project the view to the user so that he will feel
చిన్న ఒకసారి
it in the kind of a real-time view. So that's called as an augmented reality. For example, you are driving the vehicle and you are trying to drive the vehicle and you are moving the vehicle into a street, and you on your right you see a house, and if you are in a 3D view, then you see the real house, but you want to know who is there in the house, or who stays in the house. You want to know who lives in that house. So how will you get the data? So you can project augmented reality image there. So you can say that, hey, this guy lives in here. Maybe you can also say that, hey, you want to go to a McDonald's, or you want to go to a Pizza Hut. You can also you can create a augmented view to the customer so that he knows where it is and what is the price of the cafe, what is the price of the snacks. Every details comes as a augmented view to the customer. So what is self-maintained maps? So maps, we know previously we stored the maps every year. We have to store the maps inside the database. So when the maps are always in the cloud, so we just need to update the maps in the cloud. And you also want to, then obviously when the vehicle is starting, then the maps get synced into the cloud. So you get the maps automatically, and the maps are always maintained. At the same time, if there is an obstacle or it's a dynamic obstacle, if there are some things which is happening in a real time, then you can also capture the information. Then that data will be stored in the cloud. Immediately it will be transformed into the different users here and there, and which means you can also share information, and that's how you make a vehicle more connected. So when you are connected, which means not only the Bluetooth and Wi-Fi, which parts of the connectivity, you are really connected to the environment and the infrastructure and around the vehicle and around the environment completely. So what is cloud integration, OTA, and data analytics? So this is cloud, which is always a part. OTA is over-there update, and data analytics gives the information of the user who is driving, maybe the fuel data, the way he is driving, all these kind of data analytics you can collect. Artificial intelligence and machine learning. So which means this is quite a bigger topic. I'm avoiding it now because this is a critical algorithm. This needs an explanation. I mean, I would like to avoid right now. Maybe in a later part of time, maybe we can discuss it again. Vehicle mobility and insurance management, I think I have already covered this as part of the IoT, Internet of Things part. So vehicle mobility is mobility. It's not a complex topic. If you want to really know what a mobility is, Uber, Ola, what you do today, and that is really called a mobility. And what a mobility is going to help us tomorrow, and that's the question everyone has. So if you are really thinking about what a mobility is, just keep in mind what Uber and Ola today doing. That's really is the mobility. Okay. And when you say as a mobility as a tomorrow, then it comes to the topic of ride-sharing applications and how to share your drives, how to share your network, how to get the mobility into a different level. And that's the question which we are trying to solve. That's a problem we have, and we are trying to solve the problem. I also wanted to explain you on the OSA layer to how things works in a much more technical way, but I would like to stick with this as well because I have to cover these topics today. Because this is the reason why I was saying that why mobility is on the higher side. Yeah? And today, what are the trends, and what are the driving factors, and what are the new age of automotive electronics? We have a bad ecosystem today, right? We have a bad water, bad air. It's completely polluted, and nothing is good today. And from the automotive side, what we can do things to get better. And that's the reason the evolution of electric vehicles is going on today. Because with the help of an electric vehicles, there is no fuel combustion, there is no carbon dioxide emission, all these things are being happening. So which means that is the reason everyone wants to switch to electric vehicles as early as possible. So we stop the emission issues, and we will save more than 40% of air pollution. We can avoid it if we really move to electric. And sustainability, green. So for a green environment, what we have to do, that's the reason people wanted to go towards the carbon fiber vehicles. So we will reuse the waste, and let's make the vehicle in a way with let's stop steel, aluminiums. Instead, let's go to the carbon fiber. Today, the carbons are available abundant, but we do not have the right technology to use it. Yeah, that's just an example to how to sustain it. And what is future mobility? So this is the question I also asked you before. What is mobility? Mobility, we know it's kind of a Uber and Ola. How we can improve it? Because today, one person drives one vehicle every day. And what happens to that situation? If we have a ride-sharing mechanism, and what will happen during that time? Because instead of one people, we'll have 4 people using one vehicle. At least we can reduce the emission to that level. So tomorrow you park the vehicle inside. When you have an autonomous scenario comes into the picture, then the vehicle parks you into the office. Then the same vehicle can go for mobility activities also. So you can also get additional income with an autonomous driving, because you don't need to drive the vehicle. You can go to the office at the same time the vehicle goes for your business. So what are the trends right now? So we spoke about, we had previously 3G and 4G. Right now the 5G is evolving, cloud integration, sensor fusion. We need high storage. So previously what has happened, we had used a NAND flash memory. NAND memory is the usual memory which was used previously. Then people moved to hard disk drive. Now people wanted to move to solid state devices and UFS to additional memory with smaller size. And powerful processors. So when you say powerful processors, previously everything was called as the chipset. Yeah, everything was separate chipset. For example, Bluetooth, Wi-Fi, tuner, everything, media player chipset, or whatever the HMI, for the UI, for the display, everything comes with a separate chipset. Now everything is called as one unit, called as system on chip. So when you say SoC or a system on chip, then that is simply a computer as a whole. So that computer can really trigger your whole activity. So when you also have a hypervisor concept into the system, then you have one unit where we have the powerful processor into it. You also have a huge storage, and you have a common hypervisor platform. So you can try to access the multiple components in a single unit. And OTA is over there update. IoT is Internet of Things, machine learning, legalization, political changes, new agile processes. Because in automotive, people say that is it really an agile? Is the process newly formed? Yeah, agile is one of the newly formed processes which is getting evolved. Is it really possible to have an agile process into the automotive environment? Is it really possible? And then Tesla showed us to us that, hey, we are following agile and it's really possible. But for a company like Tesla, which produces maybe 100,000 vehicles or 200,000 vehicles, and they made a tin wrap software concept, it's like a completely software, the architecture is defined by software. So for them, the agile is applicable, but for the normal, traditional OEs like BMW and Mercedes, they have to still cannot completely move to agile immediately. Maybe slow and steadily they will also move. And when the Ethernet came into the picture, there is only one biggest challenge which it has. Ethernet functions on TCP protocol, transfer control protocol, which is basically based on the IP addresses. When you have an IP address, it is easy to hack the product, right? So when it is easy to hack the product, that was the biggest challenge, because even in today, Ethernet, if you are using an Ethernet, the biggest challenge is hacking. Anyone can hack your system. So if there's a security threat, then it is like you are lowering the privacy of the customer, which means you need to handle the security part. That's why the cyber security became dominant today, because of the Ethernet revolution. Urbanization and demographic changes. This is quite a small concept, because urbanization is something like previously, maybe 20 years before, what you have seen Chennai and Bangalore or other major cities is not the same as today. So there have been so much of modernization has happened in your city or the village you lived 20 years before is not the same village as you are living today. Which means there are so much of urbanization, which means so much of modern techniques which has came into the picture, and so much of vehicles, so much of machines which is dominating. So the usual tradition is not the same. It has changed a lot. At the same time, demographic changes, and people have educated a lot. Today, if you go to a dealer shop, you will start asking the people, hey, what is about the Android Auto, and what about the Google Play, and do you have a Ghana application available? Do you have a
Enter
remote
below.
locking available? You ask about all these questions because you know about these things, because you are when you try to Google, or when you look into the subjects, then you can know all the things and in today's reality, right? So which means people have educated. The same scenario, if it would have been there 20 years before, maybe your uncle or your grandfather goes to the same showroom, he will ask for, hey, what is the power of the vehicle, how much speed it goes. That's the basic question. But today it has different. So there is a changes in the demographic side. So right now, giving technology, and you can't fake the technology, and that's the main point today. Because
Is it
if you try to fake the technology, people will catch you very
Hey.
easily. Because there are many companies and people who are monitoring you very closely. So if you want to give a technology, you have to really give the technology the right way. Augmented reality, we discussed about before. Auto synchronized map with the cloud, data analytics also described. So what will happen when it comes to a new age with all these trends and the driving factors? We will be ending up in a connected vehicle, which means we call it as a connected car, or a connected services, or connected vehicle, mobility, electrification, and autonomous driving. So these are all the new age of automotive we will see in the next 20 years. Thank you. If you have any question, you can ask me, because I have covered, I had only 1 hour at a time, and my content is so much. I just want to cover things I made a bit faster during the last phases. I'm sorry for that. Thank you. Hello, Eileen, you're there?
Yeah, thank you, Karthik.
Maybe
I'll
there's
read out the queries for you.
Yeah.
Yeah, 1 minute. Okay, there's a question.
Yeah.
Yeah, 1 minute.
Mr. Karthik,
Yeah. Hello.
so you talked about Tesla electric features of Tesla electric car.
Yeah.
I'm audible. Yeah. So is it suitable for our Indian road electric car?
Definitely, it is suitable for our Indian roads, but there is one problem. We don't have the right infrastructure to power the car. For example, when you have a combustion engine, and if you want to drive from Chennai to Coimbatore, or Chennai to wherever you want to go, then you need a mileage of minimum 600 kilometers, right? So which means in a normal scenario,